Welcome back, everyone. We begin with the last part of our discussion of space technology, and here we are going to discuss about launchers. So, until now, what we have done is we discussed how satellites are launched, what is the concept behind the launch of the satellite, what are the various applications of the satellites, what are the various orbits, and what orbit is related to what kind of satellite. And we discussed about some of the special orbits as well. For example, what is Lagrange point, and what do we mean by a geosynchronous transfer orbit. So we cleared all these things, what are nanosatellites and everything we discussed. Now coming to the last bit, where we are going to discuss about the launchers. Now launchers basically will be required to launch any satellite, of course, right? So any satellite will be launched with the help of a launcher. So what we do is, if you look at typically the shape of a launcher, you'll see that it is something like this, and this topmost part is where you keep the satellite. Right, this top load most part is also called as the payload. Payload is where the satellite is kept. So whatever satellite we discussed, all these satellites will be mounted on this launch vehicle, and then it will be launched. So then you have various different types of launchers. You have PSLV XL, we have GSLVs. Before that we have had SLV, ASLV, etc. Today we have newer launchers, for example the small satellite launch vehicle. So there are all these newer launchers that we have. So overall, when we look at all these launchers and when we look at the different types of launches, first and foremost, we classify all the launchers that India has had into three different parts. First, all the historic or the retired launchers. Second, the operational ones, and third, the future or the under development ones. So historic launchers are SLV and ASLV. These are launchers that we are not using anymore, but they were a very important stepping stone for us to build the launchers that we use today. Before that, these were the launchers that we started with, we experimented with to arrive at where we are currently. So that's the first. Then after that, operational launchers. Operational launchers are the launchers that we are using today. All right, these are the launchers that we are using today. So for example, when you consider a launcher like PSLV or GSLV, sounding rockets, SSLV, LVM3, that is launch vehicle Mark 3, or also called as GSLV Mark 3, these are the launchers that we are using today, and that's why these are called as operational launchers. Then after that, there are others which are under development, which perhaps we will use in the future. Where we have RLV or reusable launch vehicle, we have the scramjet engine, and we have NGLV. So this is what we are going to discuss in this particular segment. So first, to start with the historic launchers. Historic launchers are the launchers that we are not using today. These were the launchers that we started with. For example, SLV-3. SLV-3 was the first Indian launcher, and this was used to launch a satellite. This was the first time that we launched a satellite in India, and this was Bhaskara. The launch of the Bhaskara satellite was done with the help of SLV-3. So this was the first such instance where we launched an Indian satellite with an Indian launch vehicle. Before this also we had done other launches. For example, the Aryabhatta launch was done before this, but the Aryabhatta was an Indian satellite, all right? This was an Indian satellite, but foreign launcher. Indian satellite but foreign launcher. And in this case of Bhaskara, this was an Indian satellite with Indian launcher. So that's the difference here. All right, that's the difference, and that's why Bhaskara and Aryabhatta, these two become the two prominent satellites, the first two satellites that India started launching. Now, in this particular scenario, so SLV was the first one, but if you see, it could just carry up to 40 kg of payload. Now, there was no nano satellites back then. Nano satellite is a very recent concept. Only in the last 8 to 10 years is where we have started using nano satellites. So we are here talking about 1979. This launch happened in 1979. So in 1979, of course, there was no launcher. I mean, there was no nano satellite. So that's why 40 kg meant nothing. Most of the satellites being launched back then, they were communication satellites, and these communication satellites are very heavy satellites. These are satellites which can weigh up to 4,000 to 6,000 kg. So 40 kg is nothing, but it was a very important stepping stone because this was the first Indian launcher. So at least now we were able to understand what the concept behind the launch was, and in the future we would be able to make these launches happen. So that's why SLV becomes very crucial. Then after that, we come to the next launch vehicle, that is ASLV. And ASLV had uh, it had a total capacity of up to 150 kg, which was again very good. So SLV and ASLV, these two became the first two launches. These are historic launches because these were experimental in nature and now we are not using it anymore. Then we come to the operational launches. And in the set of operational launches, the first name is of sounding rockets. Now, I'm sure you have heard about PSLV or GSLV, and if I'm not saying that you know what exactly they are, but I'm sure you have heard of it maybe in the newspaper somewhere. Sounding rockets we perhaps do not come to know about. But the interesting fact about sounding rockets is last year, India did the 200th launch. India did the 200th launch of sounding rocket, which is unique in itself. That India until now has done 200 launches of sounding rockets. We don't come to know about these launches very often because most of these launches being done by sounding rockets, they are experimental in nature, so they don't have a very real significance. Also, many of these launches that we are doing, many of these experiments that we are conducting, these are defense related, so that's why it's not publicly announced. Many a times it's very closed door operations, many a times that's why we don't come to know about many of these launches being done by all these sounding rockets. But they have, now we have completed 200 launches of sounding rockets. So sounding rockets, what we are saying is these are one or two stage solid propellant rockets used for probing the upper atmospheric regions for space research. All right, now one or two stage, understand the meaning of this word stage. Stage, in simple terms, I would say that we are talking about compartments of fuels. Stage simply would mean that there is one compartment, or there are two compartments of fuel that we are using, where we are using the fuel in this kind of a launch vehicle. Solid propellant, what is propellant? Propellant is the fuel. All right, the fuel that we are using. So when we say that it is a solid propellant means that a solid fuel is being used. For example, coal. We don't use coal in rockets, but coal is an example of a solid propellant or a solid fuel. Right. So sounding rockets, that's why very very important, because these are easy to construct, takes less time, less effort, less money, so can be done faster, and that's why for experiments largely we use sounding rockets. Then after that we come to perhaps the most important launch vehicle that India has, Polar Satellite Launch Vehicle. Now this Polar Satellite Launch Vehicle, or PSLV, has been very very crucial. Now generally speaking, when it comes to Polar Satellite Launch Vehicle, the word is polar. So if the word is polar, what kind of orbit we would use it for? Low Earth orbit, right? Largely will use it for low Earth orbit. But it's not that we use it only for the low Earth orbits. Basically, what we have seen is that we actually can use the PSLVs for different types of launches, as long as it's a lightweight satellite. So any satellite which is less than 1500 kg, any satellite which is less than 1500 kg, we can make the use of PSLVs to launch these satellites. For example, although it's a polar satellite launch vehicle and we would use it for launching the satellite in the low Earth orbit, but even Mangalyaan was launched using PSLV. Astrosat was launched using PHLV. Chandrayaan 1 was launched using PSLV. All the IRNSS satellites, they have been launched with the help of PSLVs. So it's not that PSLVs are strictly meant only for the polar satellites, As long as you have a lightweight satellite, as long as you have a satellite which weighs less than 1500 kg, we can make the use of polar satellites launch vehicle there. So that's why PSLVs can be actually used in all these cases of all the lightweight satellite. Now, PSLVs have been very, very crucial. We say that PSLVs are also called as the workhorse of ISRO. They are called as workhorse of ISRO. So why we have called it as workhorse of ISRO is that although the design was done so that we could launch polar satellites. Initially, it was done only for the polar satellites, but the way it has been constructed, we have not restricted it only to the polar satellites, but we have also used it for other applications as well. Right? So that's why polar satellite launch vehicles are not only being used for polar satellites being launched, but we see that others also, because of the success, the amount of the kind of success rate that PSLV has shown is unmatched, not only in India, across the world. Between 2007 to 2017, just giving you a random fact, 2007 to 2017, not a single launch failed. Not a single launch. No other country, no other space agency can claim something like this. That between 2007 to 17, there are almost 40 launches that we have done with the help of PSLV, and none of them failed. Such has been the success rate. And that's why, even when we were launching perhaps our most crucial of the launches, Chandrayaan 1 and Mangalyaan, in both the cases, we used PSLV. At the time of even launching Mangalyaan mission, there was so much of controversy also that was created across India. This cartoon, I'm not sure whether you've seen this cartoon or not. This cartoon was published in the New York Times at the time of Mangalyaan mission. And if you see this, what you see is that there is an elite space club. There are all these gentlemen who are sitting inside this elite space club, and then you have this person being represented. I mean, you just show the man with a cow and it represents India. So this is, I mean, a pure case of racism, nothing else. I have no better words to use here. This cartoon was published in New York Times. Perhaps, I mean, I don't believe so, but many will tell you one of the most reputed news agencies across the world. They always have had an anti-India bias, or let's say, anti-East bias, anti-India, anti-China, anti-Japan, anti-Africa. They already always have had this bias. They can't see the success of countries like these. I mean, it's as simple as that, just being blunt here. But I don't see them seeing the success. It's not against this government or that government or X or Y or Z. They always have had this stance, whether BJP or Congress or any XYZ government, that whatever has been, doesn't matter for them. They have had this kind of a bias. This cartoon was published, a lot of controversy happened. They wanted to, basically, they started asking questions that India can't even feed its population. Why do they even think of a space mission? Save money from space missions and just go and feed your population. This is the kind of statement that was being made. But you have to understand, I mean, understand this. I mean, if you have this kind of a setup in your mind, thinking that, okay, fine, I mean, maybe that's the correct logic, I wouldn't agree with it. I'll tell you why. Because when it comes to technology, when you use technology, technology is an enabler. Technology does not help you overnight. It's not that today you use some technology and tomorrow morning everything changes. Technology changes things for good. Maybe it will take 2 years of time, maybe it will take 5 years of time, maybe it will take a decade, but technology will change the things for good. Today, our agriculture is dependent on these satellite launches. Our disaster management is dependent on it. Our mobile phone communications, our internet communications, our televisions, everything, every bit of communication is being handled by all these satellites. If we were not using these satellites, if we were not investing in these satellites, and instead we just kept on giving, let's say, uh, monetary support to whatever sector needed, we would never have been able to develop. But thankfully, over the last 40 odd years, 50 odd years, the government of India, whatever government it is, they always have been focusing on this kind of a development, and that is something that has really really helped. So that's why this kind of an assumption, or this kind of an argument that you feed your population and stop thinking about space technology is pathetic, to say the least. And and they have this kind of an opinion. And look at this, I mean, I don't know what are they trying to show and what are they trying to mean here. They also apologize for it later, but uh, I don't see any merit in these kind of apologies. That if you did not want to publish this, you would not have published this. If you say you are the most reputed and one of the biggest media agencies in the world, you know what is right and what is wrong. So, but India answered in the best way possible. We had a successful Mangalyaan mission. India became the only country which has had a successful mission to Mars in the very first attempt. No other country has been able to do that. This was the, if you calculate the per kilometer cost, this was the cheapest mission that has ever been sent to Mars. I mean, per kilometer, a price of Mangalyaan mission is even lesser than what you perhaps pay for per kilometer in a cab or an auto. So even lesser than that. So that actually tells you about the importance of this. That's all, tells you how and why PSLV has been important, because all these missions, the success of all these missions partially is also attributed to the success of and the stability of the PSLVs. So PSLV, what exactly do we see with PSLV? That it is a four-stage launch vehicle where it uses solid and liquid propulsion systems alternatively. Starts with solid, then liquid, then again solid, and then again liquid. So this is how it is. So first stage, for example, if you see, it is a solid fuel. This is solid hydroxyl terminated polybutadiene, HTPB as we call it. This is the solid fuel. Then after that we have UDMH, which is the liquid fuel, unsymmetrical dimethyl hydrazine. Then again HTPB is used in the third stage, which is a solid fuel. And again the fourth stage is called as monomethyl hydrazine, or MMH, and this again is liquid. So solid, liquid, solid, and liquid. This is how the arrangement of a PSLV is. And this PSLV, there are various different types of PSLVs that we have used. And again, out of all these PSLVs that we have used over the years, most important has been this one, PSLV XL. The first PSLV XL launch was done in 2008 at the time of the launch of Chandrayaan 1. So with the launch of Chandrayaan 1, this was the first such instance where we launched this kind of a satellite. So this we use this kind of a launch vehicle, and then after that you can see that this has been one of the most widely used launch vehicles that we have used. What these variants are and what are the specifics, you don't really need to go there, although I've given one line information about all these, but I don't believe that this is important for your examination. Just as an additional information, I've given the information in the PPT itself. Then we have the Geosynchronous Satellite Launch Vehicle, or GSLV. Now, in case of a GSLV, what we see is that GSLV is three-staged. In case of PSLV, we discussed that it is four-staged. In case of GSLV, it is three-staged. The first stage again is a solid fuel, HTPB, just as we discussed for the PSLVs as well. So it has a solid fuel, which is HTPB. Then again, it has a liquid fuel, which is again UDMH, just like what we saw with the PSLV. But the third stage is where the things change, where you have something called as a cryogenic engine or a cryogenic fuel. Now, understand what is cryogenic, because cryogenic is something that is used only in the GSLVs. It is not used in the PSLVs. All right, not used in the PSLVs, only used in the GSLVs. Cryogenic, whenever you see something, any word which has cryo, wherever you see this word cryo, understand that we are talking about very low temperature. Cryo means very low temperature. So cryogenic is any technology that works at very low temperature. Now, when I say very low temperature, the meaning is it can be less than minus 150 degrees Celsius or even less than minus 200 degrees Celsius. So very low does not mean 5 degrees or 0 degrees Celsius. Very low here means a temperature of even lesser than minus 150 degrees Celsius. So we are talking about a very drastically low temperature. All right. So now in this scenario, what we see is that cryogenic is used in the third stage, and this completely changes the configuration of GSLVs, because GSLVs are heavier launch vehicles. We are using it to launch communication satellites. Now communication satellites, they are often greater than 2000 kg. They can be as huge or as massive as 6000 kg. Whereas on the other hand, the Earth observation satellites that we are launching with the help of PSLVs, they largely are of the order of 600 to 700 kg only. And here we are talking about satellites which are 4000 to 5000 to 6000 degrees 6000 kg. So that is what we see with GSLVs, that GSLVs are heavier launch vehicle. And the cryogenic technology that we are using here, this cryogenic technology has been at the center of the development of this GSLV, because GSLVs, they have to carry more load. For that we needed stronger fuel, which is the cryogenic fuel. And getting this cryogenic fuel also has not been that easy. Development of this cryogenic fuel has taken a lot of time. It has taken a lot of time and a lot of effort for India to finally uh, get this cryogenic fuel and be able to make this cryogenic fuel. There's a wonderful book actually written where all these actually the stories are also present. There is a book called as ISRO, a personal story. Anyone interested? A wonderful book to read. So it talks about how difficult it has been, how difficult the journey has been, but still we have been able to uh, do everything possible. We still have been able to get to our targets and do whatever was there in our own stance. So that's why getting cryogenic has been important, because there are only handful of countries in the world which know how to use cryogenic technology. So that's why strategically it has been very very important. And not only for the satellites, cryogenic fuel can also be used in the fighter aircrafts and also the missiles. So it's not only something that helps our space missions, it also is something that helps our defense. So again, coming back to the discussion that we had, that why spend on technology, feed your population, why is it wrong? When we developed this cryogenic technology, although it was first developed for our GSLVs, but it's not that our fighter aircrafts will not use it. It's not that our missiles will not use it. So some a technology that was developed for space is also being used for defense. So there are two sectors in India that are able to gain from the development of one technology. So that's why we need to understand that how in a long term growth aspect, when we look at these kind of technologies, they often help the country. So this is what we have seen with GSLVs. Now, in case of GSLVs, we have seen that there have been three different variants of GSLVs: GSLV Mark 1, GSLV Mark 2, and GSLV Mark 3. Now, in case of GSLV Mark 1, all right, GSLV Mark 1 and Mark 2, if you see, they are very close, they are very similar. The height is the same, the lift of mass almost the same, number of stages the same, the payload that they can carry to the low Earth orbit, same 5000 kg in both the cases. Payload that they can carry to the geosynchronous transfer orbit, again the same 2500 kg. But Mark 3 is very different. Height is different, lift of mass significantly improved, stages 3, but again the kind of cryogenic that GSLV Mark 3 uses is different compared to Mark 1 and Mark 2. Then again, 8000 kg can be carried to the low Earth orbit, 4000 kg can be carried to the GTO. So then in that case, it's a great improvement that we have. And what we have seen is of late, GSLV Mark 3 as a term is not being used by ISRO and the ISRO officials. They have started using the term launch vehicle Mark 3. They started using the term launch vehicle Mark 3. So understand this, that whether if you see the mention of launch vehicle Mark 3, if you see the mention of GSLV Mark 3, we basically mean the same thing. All right. Both of them are the same. Just that of late we have seen that ISRO has been talking about LMV3, LVM3 instead of GSLV Mark 3. Although there is no difference in design, there is nothing. That's the only thing is that they are saying that okay, because there is so much of difference between GSLV Mark 2 and Mark 1 versus GSLV Mark 3. Let's not call this as a version of GSLV. Let's call it as Mark 3. I mean, Launch Vehicle Mark 3. So that's why just understand this. I mean, in the newspapers, if you come across the term GSLV Mark 3, if you come across the term LVM Mark 3, both mean the same. All right. So this is what we have seen with the GSLVs and largely being used for communication satellites. Look at this question. Just read the question and then I'll launch the poll for you so that you can mark your answers. I hope you have read the question. I'm launching the poll for you. Please mark your answers. Yeah. So, okay, 64% of you have marked A, 9% B, 5% C, and 23% D. Okay, so let me discuss this with you. So, the question says with reference to India's satellite launch vehicles, consider the following statements. The first statement is PSLVs launch the satellite useful for Earth resource monitoring. We discussed this, that Earth observation or uh, all these things are done by these satellites, whereas GSLVs are designed mainly to launch communication satellites. This is also correct. So this is also correct. So correct, statement number one is right. Satellites launched by PSLV appear to remain permanently fixed in the same position in the sky as viewed from a particular location on the Earth. This is something that we discussed for high Earth orbit, right? In high Earth orbit, we discussed that when you are at 35,786 kilometers, then in that case, you are permanently fixed. Now, what satellite launch vehicle are we using for high Earth orbit? Is it PSLV or is it GSLV? Communication satellites are being launched by GSLVs. So, this is wrong. This is not PSLV, this is GSLV, because it's the communication satellite which is at 35,786 kilometers, which will remain permanently fixed with regards to a point on the Earth. So that's why this is wrong. Third statement, GSLV Mark 3 is a fourth stage. This is wrong. How many stages for GSLV Mark 3? Three stages: solid, liquid, and cryogenic. So the statement says GSLV Mark 3 is a four-stage launch vehicle with the first and third stages using solid rocket motors and the second and the fourth stages using liquid rocket motor engines. What is this? This is PSLV. This is PSLV. This is what we discussed with PSLVs. That first stage is solid, second is liquid, third is solid, fourth is liquid. Correct? So this is basically how we are going. So that's why this is also wrong. Correct answer will be A, one only. Moving on, the next topic for us is Vikas engine. Now, Vikas engine again has been one of the most important parts of India's success story. Why so? Mainly because of the fact that Vikas engine also has been developed in a manner that it made the second stage, that is the liquid stage, uh, very stable. Because what we have seen all across the world, that stabilizing the liquid stage has not been very easy for many other countries. In this regard, India also was struggling initially, no doubt about that. But then after that, we were able to change this when we developed the Vikas engine, which basically was based on the licensed version of the Viking engine. So Viking engine is something that we got from France. Viking engine is something that we got from France, and we developed Vikas engine from Viking. And Vikas basically was named after Vikram Sarabhai. So it was a name that we took from Vikram Sarabhai. In his honor, this name Vikas was given to this satellite launch vehicle. Sorry, this engine. And this engine basically is used for the liquid fuel, to stabilize the liquid fuel. So in the second stage of PSLV, the second stage of GSLV, the fourth stage of PSLV, in all these cases, Vikas engine has been very, very crucial. So that's why we see that in all these cases, it became very, very crucial from perspective of uh, the development of liquid stages in India. Now, one more satellite launch vehicle, which is a new addition to the Indian setup, is small satellite launch vehicle. What we discussed earlier was about the small satellites and how small satellites are so useful and why they have started gaining a market in India and internationally. That's why, keeping that in mind, keeping the mind the in the mind the advantages of the small satellites that we have, we launched the small satellite launch vehicle, so that the launches of the small satellites can be done in a much more focused manner as compared to what we do today. So that is the entire reason why we switched to this kind of a setup. Now, in case of a small satellite launch vehicle, we see that this is something that will be a three stage solid propulsion launch vehicle, which will also have a liquid propulsion in the velocity trimming module. Basically, it is a three stage launch vehicle, one, two, and three stage launch vehicle. And then after that, there will be a velocity trimming module, which will be liquid, and all these other three stages, they will be solid. Now, why liquid engine or liquid module is required here is for stability, is for control and stability. So, very simply put, what we see is that controlling the flow of liquid fuel is much easier as compared to controlling the flow of solid fuel, because once the solid fuel starts burning, it's very difficult to uh, stop it or control it. Whereas in case of liquid fuel, we always see that it's easier to control liquid fuel. And that's why in the uppermost layer, most of the times you'll see that solid fuel will never be used, because control is a very important factor there. So that is why small satellite launch vehicle will be used here. So of course, for launching all the satellites which are less than 500 kg, we can use small satellite launch vehicle. And not only the fact that we can use small satellite launch vehicle, uh, we can launch the small satellites, but at the same time, not only Indian but also foreign satellites, not only public but also private satellites, all these launches can be done now. So that's why it becomes a big source of revenue generation for India. And that's why the operations have been given to NSIL. We'll discuss about NSIL a little later. So NSIL will be looking after the operations of SSLV. NSIL will be looking after the operations of SSLV. So SSLV becomes a very, very important new addition. So until now, all these are operational. PSLVs are operational, sounding rockets are operational, GSLVs are operational, and SSLVs are operational. Now we come to the future of what we want to do in the coming decade. So first there is scramjet. Now scramjet, when it comes to it, scramjet engine is a special kind of engine where what we see is that these are engines where these are called as air breathing engines. We say that these are air breathing engines. What is the meaning of air breathing engines? That they would be able to use oxygen present in the atmosphere as oxidizer. Now let me tell you what the problem is and what problem are we trying to solve. Every fuel every fuel for its combustion needs oxygen or needs an oxidizer. Even let's say, even if you are trying to light a matchstick, you are able to light the matchstick only because the earth's atmosphere has 21% oxygen. Suppose a hypothetical scenario where oxygen is not there in our atmosphere. What happens then? Combustion can't happen. All right, because oxygen supports that combustion. I mean, of course, it's another question that we'll all die because we breathe in oxygen, but I'm not going there. I'm talking about combustion. So, in case of combustion, what happens is that for any kind of combustion to happen, you need either oxygen or you need an oxidizer that will support that combustion. So, now then what happens is that if, let's say, even a launch vehicle is used for any satellite launch, apart from all the fuel that it will also carry a lot of oxidizers. All right, it will also carry a lot of oxidizers, and all these oxidizers also take up a lot of space, also increase the total mass of the launch vehicle. So overall, it's not a good deal. That partially is something that we want to solve with scramjet. With scramjet, what we basically see, scramjet stands for SC ramjet. SC is supersonic combustion. Supersonic combustion ramjet air breathing engines. So what it does is, if you look at this particular figure, what happens is that if, let's say, this engine is moving in the forward direction like this, if it is moving in the forward direction like this, then air or oxygen is entering inside this scramjet engine from here. All right, so now what happens is that as it enters, it also gets compressed here, it also gets compressed here, and the temperature starts to rise. So here you have high temperature, here you have high temperature, and at this high temperature the fuel is injected. The fuel is injected, and as soon as the fuel gets injected, fuel comes in contact with oxygen, the temperature is high, combustion of the fuel starts. Combustion of the fuel starts and the engine will keep on running. So now what you do, we have been able to save a lot of oxidizer, because then we don't need to carry the oxidizer, at least in the first stage, which is in the lower part of the atmosphere. We don't need to carry oxidizer. Yes, of course, once you go in the higher atmosphere or beyond the earth's atmosphere, there is no oxygen, so there still you will have to use oxidizer. But at least in the first stage, which is in the ground, which is in the lower part of the atmosphere, at least there you don't have to use the oxidizer. You can use the scramjet engine, which will help you in reducing the weight of the launch vehicle. Reduce the launch vehicle weight, you will be able to reduce the amount of fuel used, you'll be able to increase the capacity, you'll be able to increase the speed. So there are multiple advantages that we will have. So that's why scramjet. So scramjet, what all advantages? First of all, no oxidizer to be carried. No oxidizer to be carried, so less fuel consumption. Less fuel consumption, becomes cost effective. Becomes cost effective. becomes environmentally friendly, increases the capacity, and one more very very important point, can be used can be used for both satellites and missiles. So, for example, we you might have heard of the BrahMos missile. So, in the BrahMos missile, also we are trying to fit the scramjet. So, it will have an advantage for us even in our defense technology. So, that's why there are all these advantages that we have with scramjet. We have already done one research. We have already done one test, and the test was successful. Although the test it has been almost 7 years now. The test was conducted in 2016. It was completely successful. Of late also there has been news about scramjet and new testing of scramjet that has started now, and in the coming years we are expecting that scramjet in one form or the other will be used by ISRO in some launch vehicle. So this is one. Then after that, another technology that ISRO has been working on is reusable launch vehicle. So reusable launch vehicle also tested back in 2015. Again, recently there was news about reusable launch vehicle and how India is moving forward with the plan, and there are new tests that have happened. Now, with reusable launch vehicle, of course, the advantage is the name reusable launch vehicle, meaning that this is a launch vehicle which can be partially used again. If you see this, if you see this picture, what we basically will be doing is that once the launch vehicle has been launched, once it has launched the satellite, it will drop down, it will be collected, and it can be reused. So partially we'll see that reusing the satellite launch vehicle will be possible. So that also will be a big thing, because again, you save money, you save some effort, you save time, and there are all these advantages that we have here. So that's why reusable launch vehicle also becomes a very crucial part of this entire setup. Then after that, there is another new discussion that has been happening, which ISRO probably has initiated last to last year, I would say, is about NGLV. Last year there was a conference also where NGLV was talked about. What NGLV is? Next generation launch vehicle. Now, this next generation launch vehicle is something that ISRO is planning, where this will be a much heavier launch vehicle as compared to whatever we have. So, for example, even with GSLV Mark III, our capacity has gone up to 4,000 kg for GTO. But many of the satellites that we launch, they're not just 4,000 kg. They are 5,000, 6,000, more than 6,000 kg. So then what happens? We can't launch it. We have to go to some other country to get it launched. Most of the times we go to France and we use their launch vehicle called as Ariane 5 or Ariane 6 to get the launches done. So now we want to build that capacity that we should be completely independent. We already are 90% independent, but we want to be completely independent and not rely on anyone else for our launches. So this is where the concept of NGLV comes, where they are trying to make a cost effective three stage to orbit reusable heavy lift vehicle which can go which can have a capacity of up to 10 tons, that is capacity of up to 10,000 kg, up to 10,000 kg to GTO. Whereas right now we have just up to 4,000 kg with GSLV Mark III. So a significant improvement is what we are looking for. And here they will be using a semi-cryogenic propulsion. So semi-cryogenic is where with cryogenic, kerosene is also mixed. Kerosene plus cryogenic. This was also in the news. Very recently, we have tested out semi-cryogenic engine just a couple of months back. So already we are moving forward with the plan, and that's why we see that all these smaller components here and there, they are being tested. And later on, we perhaps will see that all these will be used. Then lastly, the fuel that we are using. So we discussed about HTPB, that it is the solid fuel that we use, and HTPB is being used in the first and the third stages of f- first and third stages of PSLV. Then again first stage of GSLV, and all three stages of SSLV. Then you have UDMH. So UDMH is used in the second stage of both PSLV as well as GSLV. All right. And then after that we have MMH. MMH is used in the fourth stage of PSLV, and the velocity trimming module in the SSLV. So there also we see that MMH is being used. Then after that you have LOX and LH. LOX stands for liquid oxygen, which acts as an oxidizer in the cryogenic engine. So we discussed that there is a cryogenic technology in a cryogenic engine which works at a very low temperature, where you have a mixture of liquid oxygen and liquid hydrogen. It uses a mixture of liquid oxygen and liquid hydrogen, where you have liquid oxygen that acts as an oxidizer, and you have liquid hydrogen which acts as a fuel. All right, it acts as a fuel. So that is what we are looking at. So it is the liquid form of hydrogen used in the fuel in the cryogenic engine. So for liquid oxygen you need almost minus 150 degrees Celsius. For liquid hydrogen you need almost minus 250 degrees Celsius. And then there is MON, which is mixed oxides of nitrogen, again something that we are using as the oxidizing agent or the oxidizer to be mixed along with the solid or the liquid fuel. So this is how we see that all these fuel also are being used in this entire setup of what ISRO has. Right. If you have any questions, please let me know before we go on to Indian Space Research Organization or ISRO. If you have any doubts, please let me know. Plus, we use PSLV and GSLV for higher payload capacity. Not exactly. See, just understand this, that where exactly we'll be using what? We'll be using SSLV for up to 500 kg. SSLV for up to 500 kg, PSLV for up to 1500 kg, and GSLVs above 1500 kg. So this is a typical setup. Why the name polar? Polar name has been given mainly because the primary purpose has been polar satellites. Primary purpose has been polar orbit. That's why the name PSLV starts with polar. But we know that we can use it for other purposes as well. Times of India replied this when India recorded 101 satellites. Of course, yeah. In 2017, when we were able to achieve the feat of 104 satellites, Times of India had replied to it. Absolutely correct. What is HTPB? It is hydroxyl terminated polybutadiene, which is the solid fuel that we are using in our setup. How revenue? I don't know Avni, in what context you have asked this question. Please repeat this question with the context, so I'll be able to answer you. How to remember all the things? You will have to revise. That's the only way to remember all the things. You just go through all the stories that we have discussed one or two times. It's easy, not difficult. In which state is cryogenic fuel? Liquid state. Please open last slide for a second. Last slide. If you're asking for this, this is the last slide. What does the word polar indicate in PSLV? Polar indicates that you are primarily going to launch the satellite into the polar orbit. Right? We discussed about the low Earth orbit where you have the polar orbit. So that is what polar indicates. Can I make all a table for all the things? Yes, of course. I mean, if it helps you, why not? I mean, you anyway have to make notes so that you can revise. So it will all help you. For what SSLV is used? As I told you, SSLVs will be used for small satellites. For the satellites which are less than 500 kg, to launch all these satellites, will be using SSLVs. Solid fuel, like solid fuel, I mean anything that is in the solid state. Any fuel that you use in the solid state will be called as a solid fuel. That's why I gave the example of coal. That coal can be called as a solid fuel because it is in the solid state when you use to come for it, use it for combustion. So that's why solid. So HTPB is the solid fuel that we use here. Any country has functional scramjet, has heard of it, have heard of it in defense and missiles. Yes, scramjet is already functional in some of the other parts of the world. US has it, even Russia has it. I think Israel also, if I'm not wrong, has it already. India also has developed it. I mean, we have tested it successfully, and we also will be using in defense also. We will be using it in BrahMos missile along with our own satellite launch vehicles as well. Okay, any other question? All right. Rohini satellite. So Rohini satellite in 1980 we had launched with the help of SLV-3, and Bhaskara 2 was the one that we had launched with the help of uh, the same SLV-3. Hmm. So let's move on. The next topic for us is Indian Space Research Organization, or ISRO. So here there are few things that we should know about ISRO as well. Uh, First and foremost, what exactly does ISRO do? Anything related to satellites, anything related to the space programs in India, anything related to the space sector in India, ISRO becomes the most important organization, right? So what is the vision? The vision that ISRO has is to harness space technology for national development while pursuing space science research and planetary exploration. Now things have been made very clear here. Most important application, most important work that ISRO will be using satellites for will be national development. Look at all the satellites that we have launched over the years. There are so many Earth observation satellites for agricultural purposes, for climate change studies, for disaster management, for traffic management, for urban development, for ocean resource management, for petroleum reserves. So there are so many of them. Plus, there are so many communication satellites for telephone, for telemedicine, for teleeducation, for internet, for mobile communication. And then there are all these navigation satellites that we have launched. So you'll see that primarily we have been launching only the satellites for all these purposes, which will help India and people of India in one way or the other. And there are very few satellites which are not in the purview of all these applications. Chandrayaan 1, Chandrayaan 2, Mangalyaan, and Astrosat. That's it. Only four. And then after that, we are now planning Chandrayaan 3 and Aditya L1 and the Gaganyaan mission. So when you count the numbers, there is no comparison. On one hand, we have launched more than 100 such satellites which are required for some kind of Indian application. And then there are just four that we have launched for some kind of study which is beyond the direct application for people of India. So that's why we have seen that this word national development is very, very important. And this one line, the statement, the vision statement is crucially important. That if at all, let's say there is a question in your mains examination, or you are writing an essay where it is related to the scientific developments in India, this is one statement that if you could use, it will always help enhance the quality of your answer. Mission statements you don't need to remember. I've given you the details. It's nothing but everything that ISRO does. So that's the detail of it. No need to remember it by heart by any means. Look at the organizational structure of ISRO. That what are the various work and various things that ISRO has been doing. So first and foremost, when we look at the organizational structure, what we see here is that what we see here is that it all comes under the Prime Minister. You have Department of Space, and under Department of Space there are so many things. Now when it comes to ISRO, all these units of ISRO, they become important, plus these two are important, plus in space is important, others not so much. And in just one line, just remember what they do. All right, so first, for example, we have Vikram Sarabhai Space Center, VSSC. Vikram Sarabhai Space Center. So Vikram Sarabhai Space Center, the basic idea behind Vikram Sarabhai Space Center is that it helps in the design and development of the launch vehicles. So everything with regards to launch vehicles, even what kind of paint will be used in launch vehicles, all these things will be done at Vikram Sarabhai Space Center. Then we have Liquid Propulsion Systems Center, LPSC. So this is basically where we see that all the fuel fabrication happens. All the fuel fabrication is done at LPSC. Then after that you have SDSC, that is Satish Dhawan Space Center, located at Sriharikota, and this is the launch base infrastructure. This is where all the launches that India does, all the launches are done at Sriharikota at Satish Dhawan Space Center. Then after that we have URSC, that is UR Rao Satellite Center. So UR Rao Satellite Center is where the design and development of all the satellites are done. Design and development of all the satellites are done at UR Rao Satellite Center. Then you have SAC. SAC stands for Space Application Center. Space Application Center. So what we see with Space Application Center is that it is responsible for the design and development of all the components and instruments, etc. The sensors, the optics, etc. All these are uh, manufactured at Space Application Center. So the instruments, the sensors, the various components to be used in a satellite. So anything that is being developed here, what we basically see is that all these things will be developed here and then it will go to URL Satellite Center where the final fabrication will happen. Then after that we have NRSC. NRSC. So NRSC is basically National Remote Sensing Center, and this is the center which keeps on receiving all the information from the remote sensing satellites. All the pictures, all the videos, all the data collected by the remote sensing satellites, they're all they're all sent to the National Remote Sensing Center, where we see that all the processing of the data is done. All right. So data processing of remote sensing satellites or remote sensing data. So all these things will happen at National Remote Sensing Center. And then lastly, we have HSFC. HSFC basically is Human Space Flight Center. HSFC is Human Space Flight Center. And the basic role of Human Space Flight Center is to look after all the applications and all the things that we are going to do in the human space flights. So, for example, the Gaganyaan mission. All the operations of the Gaganyaan mission are right now being looked after by the Human Space Flight Center. And it's a very new addition. All these other units that we have discussed, they have been here for, let's say, almost 20 years, more than that. Human Space Flight Center was added just in 2019 so that every operation of the human space flights that we are considering, that we are developing, we can look after the operations of all these with the help of the Human Space Flight Center. So that's why HSFC was developed. So to look after the human space flight operations. Now after this we have two more units. We have Antrix and NSIL. These are also called as commercial arms of ISRO. They are called as commercial arms of ISRO. Commercial arms of ISRO. Why? Because every commercial activity that ISRO carries on, all these things will be looked after by Antrix and NSIL. Here also, Antrix has been here for a very long time, almost more than 20 years again. But in case of NSIL, again, it's a new addition and was just added in 2019. So NSIL basically all the newer operations of the private dealings of the private launches that we are planning, uh, talking to the private companies, talking to the foreign agencies, all these things will be taken care of by NSIL. And that's why even the operations of SSLV is being looked after by NSIL. So NSIL has started taking a lot of jobs in the private sector, doing helping in the growth of the private sector as well. And along with NSIL, there is another segment that works along with it, which is in space. That is Indian National Space Promotion and Authorization Center. Now, in case of in space, the basic role of in space is to help in the growth of private space sector or in India. So whatever startups, etc., they are working, the training, the promotion, the authorization, giving the work to them, all these things are also being done by InSpace. So that's why InSpace works very closely with NSIL to provide all this help to the private companies, especially the Indian startups that are there in this segment. So that's why this is, you can say, the basic organizational structure, and these are some of the important units and some of the important areas of what ISRO has been doing. Now, overall, when you look at the space centers or the ISRO centers, you'll see that all these are the various centers that you have. A lot of them, most of it, you'll see that are in the southern part of the country, for a very simple reason that the launch has to happen from here, from Sriharikota. So that's why if, let's say, the satellite development and everything happens, let's say, somewhere in Delhi, and then you have to carry from Delhi to Sriharikota, it will be very difficult job. So that's why we have seen that a lot of setup, most of the setup for ISRO is there in the southern part of the country. Bengaluru has been one of the most important centers. The headquarters are there in Bengaluru, and then after that, you have other centers also that you have here. Now, apart from all this, there is one more thing that I want to discuss with you, And this is about a new spaceport also that India has been working on, which is located at Kulasekrapatnam. All right. So if you see Kulasekrapatnam, you have here. Until now, the launches that we are doing, we have been doing from here. This is where you have Sriharikota. All right. This is where you have Sriharikota. So Sriharikota is where all the launches happen from. But in the future, we also want to move to Kulasekrapatnam, or some of the operations would go to Kulasekrapatnam. Why? There are a couple of things that you should note here. That first of all, whenever any launch is done, you'll always see two things. That launches are also always done from the eastern coast. All right. Launches are always done from the eastern coast, and the launches are often done towards the equator. So the launches are done from the eastern coast and the launches are done towards the equator. Now, why? All right. Why exactly do we do that? So understand few points about what exactly are we trying to gain here. That why Sriharikota? Why didn't we choose something from the western coast, maybe Karnataka, maybe Maharashtra, maybe Kerala? Why not? Why did we choose Sriharikota? Second, why do we do the launches towards the equator? What you'll also find is that a lot of launches that happen, they often happen from the tropical areas or any point which is near the equator. For example, even these points will be considered near the equator. So why? So understand couple of points. That first of all, why are we using the eastern coast? Why do we do the launches towards the eastern coast? From the eastern coast is because the launches are always done eastward. The launches are always done eastward. So let's say if we had chosen a point on the western coast, suppose that we had chosen a point on the western coast and then we had to do an eastward launch, there will be a safety issue because you are launching the satellite over the Indian landmass. What if something fails? What if something happens, an accident? It will be a major problem. So that's why east coast, because the launch has to be done eastward. So east coast, so that there is no problem whatsoever that we create. Why eastward? All right. Why eastward? So eastern coast is chosen because launches are done eastward. Launches are done eastward. Why? So that we can gain from the earth's rotation. Rotation of the earth happens how? You might know this, west to east. So rotation is happening from west to east. We launch eastward. So what happens is that it gains speed because of that. Makes it easier. That if let's say you're doing a westward launch, then you would have to add more thrust. You'll have to have more. You'll have to use more fuel. But when you're doing an eastward launch, it makes it easy because Earth is rotating from west to east. You launch it eastward, you'll be able to gain the velocity there, and with lesser fuel, you can do the launch. So that's why we always do the launch from the eastern coast. Then, secondly, the launch is always done towards the equator or at least near the equator. Why exactly do we do that? We do this because the rotation of the earth also is not constant, it is variable. The rotational speed near the equator is higher, rotational speed away from the equator is lower. So then in that case what happens is that launches become easy because you are able to gain from that higher speed of rotation near the equator. So this is done because we have a higher rotation speed, sorry, not near, but rather at the equator. All right. So that's why these two always are done. Now understand one problem, that we are not using this kind of a point because we don't want to fly over the Indian landmass. But when we do the launch towards equator, the Sri Lankan landmass also comes into the picture. We can't do this kind of a launch, right? It's not only Indian lives that matter, every life matters. Correct. So the launch basically will be done like this. Now when the launch is done like this, it's a bigger path. You use more fuel, right? You use more fuel, so ultimately not very cost effective. When we are at Kulasekhara right here, the launch can be done towards the equator without having to increase the path length, because Sri Lanka can be avoided very easily without any problem. So that is the reason why we are thinking of a new spaceport, so that we can also do some cost saving with this kind of a setup. So that's why all these are the steps that are being taken by India. So again, some basic concept, but remember, can be very, very important. Now then, lastly, one there are a couple of small topics that we have here. One about the international treaties. Just in one line, remember many treaties, because there are a lot of launches that we are doing. So you should just know that what are the rules, what are the international laws that we abide by while doing any launch. So there is something called as an outer space treaty, and the outer space treaty looks after all the operations of the various different launches that are being done either by India or by many of the other countries. Most of the biggest of the countries and biggest of the uh, space agencies, they are a part of this outer space treaty, which governs the activities of the states in the exploration and the use of the outer space. So there is, for example, the rescue agreement. The rescue agreement talks about the rescue of the astronauts, return of the astronauts, and the return of the objects that are launched into the outer space. That anything that we are launching, we have to ensure that we can bring it back. Or if there is any capacity that any other agency has to help, let's say an Indian launch is facing some kind of a problem, and the Chinese agency can help India there. So it becomes the duty of the Chinese agency to help India, because they are also abiding by the rescue agreement. Similarly, we have the liability convention. The liability convention talks about the fact that the liability of any problem lies with the country that has caused the liability. For example, let's say uh, India launched a satellite, and this satellite goes and collides with a Chinese satellite. Now Chinese satellite was already present there, India was the second to go. In that case, the liability lies on India, that India will have to pay for the damages that India has caused. Not only that, let's say India launches a satellite for Bangladesh or launches a satellite for Bhutan, and that satellite goes and collides with another satellite. Even then, the liability lies on India, not on Bangladesh or Bhutan, because they did not launch the satellite, India launched it. So whatever agency has launched it, they will be liable for the damages. Then there is registration convention, which simply talks about the fact that anything that you are launching, you have to first register it. Any object that you are sending to space, register it first. And then lastly, we have the moon agreement. The moon agreement basically talks about all the activities of the state on moon or any other celestial bodies. That when we are going to the moon, for example, it becomes relevant from Chandrayaan 3 mission perspective, that while we are going to the moon, whatever activities that we are conducting on the moon, all these things will be bound by the moon agreement. We are a part of it, and we'll abide by the rules of whatever the moon agreement says. Then again, one small topic is International Space Station. International Space Station has been in the news in the last 1 year, mainly because of the Russia-Ukraine war and the issue there. That initially, because when it comes to International Space Station, there are five participating agencies. You have NASA, you have Roscosmos, you have JAXA, you have European Space Agency, and Canadian Space Agency. Now, when the issue started, the other countries said that we don't want to collaborate on any project with Russia, and we want Russia to go away from the International Space Station. Russia said that we manage the operations of International Space Station, we won't go away, and if we go, you will collapse. So all these controversies started. Later on, Russia said that anyway we are going to exit over the next few years. We are going to exit from International Space Station, and we'll be building our own personal space station, uh, which will for us will be a replacement of the International Space Station. So because of this, we saw that there was a controversy that happened. Basically, International Space Station is used for a lot of experiments that we conduct there, a lot of understanding of the space environment and how human body or other organisms, etc., how they behave in these kind of uh, uh, environments. All these are done there. Plus, any support that has to be provided to any satellite which is in the low Earth orbit, all this support can also be provided by the International Space Station. So that's why it has its own relevance here. India is not a part of it. There were some talks that India perhaps will become a part of it, but then India announced that India is going to work on its own space station. And by 2030, we have taken the target year of 2030, that 2030, India will also have its space station, the Indian space station, which will be an independent one that India will be trying to build by 2030. So India is working here, China is working here, Russia already is saying that they'll be doing it independently. So we see that a kind of an Eastern Bloc also is working in this space agents, space war. Now, last topic for us is space debris. Now, space debris because basically is nothing but the debris or the junk that we have sent to space. Anything which is man-made, anything that is not natural and is present in the space is called as space debris. Today what we are seeing is that the numbers have been increasing because there are so many launches that we are doing, not only India, across the world. The number of launches in the last 10 years perhaps surpassed any launch that we have done in the last 50 odd years. So many launches have happened, and most of these launches have been done to the low Earth orbit. So that's why low Earth orbit especially has become very problematic. Now, in this scenario, when we look at the distribution of all the objects that we have, we see that there are 65% of the non-functional objects that we have. There are only 7% of the functional satellites, and it's a big number that there are 28% of just fractions, very small fragments that are there in the space. And that's why when you look at the numbers, you'll see that the numbers are astonishing. That there are 4,000 active satellites, 3,000 dead satellites, 34,000 pieces of junk which are larger than 10 centimeters, 128 million pieces of space debris which are larger than 1 millimeter. So that's why the numbers are increasing, and that's why it is becoming a major problem as we go along. And there is a concept also called as the Kessler syndrome. This was an idea that was proposed by a NASA scientist who goes by the name Donald Kessler. And he said that there could be a situation in the future where so much of so many satellites will be launched that there could be a chain reaction that could be set up, that two satellites might collide, because of which a lot of debris will be created. Other satellites which are also in the same orbit will come across these uh, uh, fragments, and they will also meet with an accident, and it will lead to a chain reaction, so much so that this entire orbit might become unusable. We slowly and steadily are reaching that stage where all these things can become a reality. And that's why we are today trying to understand, how to get rid of all these things. So today we have started working, that today we have started to clean up the space debris. There are multiple such efforts. For example, India is working on something called as the Netra project. Then apart from that, we see that NASA has been working, Japanese Space Agency has been working, European Space Agency has been working. All of these space agencies have been working on various different technologies so that we can start cleaning up the space debris that we have created over time. So overall, we see that all these things are happening, but we understand essentially that the problem has been increasing now, and we need to take a concrete step very quickly as soon as possible. So, so that's why these smaller concepts from the perspective of examination can become very, very important for you. So keep a track of whatever is happening with space debris and International Space Station, etc., can be important for your examination next year. So this ends the first chapter, probably the biggest chapter that we have of out of all the chapters. If you have any doubts, you can ask them. Let's take a small break here. Let's be back in 10 minutes and then we will move to our next topic, that is energy. So if you have any doubts, please let me know. What is the difference between ISRO and Indian Space Station? See, Space Station is just a station. ISRO is an agency. It's an organization that is looking after all the space activities that India does. This should not even be a question. All right. So if you have questions, you can keep posting. When we come back from the break, we can again look into all this. Let's be back by 7:05 p.m. and we'll move into our last topic. Welcome back, everyone. Now we begin with our second chapter. So, in the first chapter, we discussed everything about space technology and everything related to space technology. Moving on to the second chapter, that is energy. Again, a chapter which is very, very important for the examination. A chapter where we expect a lot of questions to come. It's a chapter from where we do see a lot of questions, and both at prelims as well as at the mains level, you have to expect that questions will come. Now, when it comes to energy as a chapter, it is not a single chapter, I would say, but rather this is a chapter where there are a lot of things that it covers. In a manner, you can say that there are three different chapters that we are looking at, or three or four different chapters that is combined as one single unit. So now, when we look at energy as a chapter, first and foremost, what we will be discussing is, first we'll try to understand what is energy, what are various different forms of energy, and then each and every one of these forms of energy, one by one, we'll try to go and try and understand what these energy forms are. So first, what do we mean by energy? Now, in simple terms, what we see is that energy is the capacity to do work. But we are not really talking about the physics of energy here, but rather this chapter is more about the sources of energy. That what are the various different sources of energy? Now, for one, we know that there is coal, there is petroleum. Today, we are working on solar energy, wind energy, biofuels, geothermal energy, nuclear energy. There are so many different forms of energy that we have here. Hydrogen has emerged as one of the newer sources of energy. So, we know that there are so many of these different sources of energy that we have had. Now, when it comes to energy as a source, what we see is that there are various ways. First of all, we'll try to understand how do we classify energy. So, the first way to classify energy is on the basis of what is renewable and what is non-renewable energy. Now, try to understand how exactly do we classify something as renewable energy and when do we classify something as a non-renewable energy. What is renewable and what is non-renewable for us? Let's try to understand that first. So when we say that something is renewable energy, it simply means that renewable means that okay, fine, we can renew. But when I'm saying that we can renew, how fast should it be renewable? That let's say something is renewable in 10 years of time. That you spend everything today, 10 years later, you will again replenish that source. Would you call it as renewable? You perhaps will not. Because when we say renewable energy, we would want a constant supply of that energy. We would want that that energy is always available for us and we don't have to worry about consumption of that energy. So that's why, in a manner, when we say that something is renewable energy, we basically try to say that these are energy sources where replacement rate replacement rate is faster than consumption rate. Replacement rate is faster than the consumption rate. All right. So, meaning that whatever be your consumption rate, you are able to renew it faster. Then, in that case, we'll say that okay, fine, this is a renewable energy source. So, we have solar energy, we have wind energy, we have geothermal energy, we have biofuels. All these can be called as renewable energy sources. On the other hand, we have non renewable energy sources where the things are opposite, where your consumption rate is faster and your renewable or the replacement rate is slower. Take coal for example. How much time does it take for coal formation to happen? Anyone who knows, anyone who can tell me? How many years does it take for coal to form? One simple question for you. Okay, some of you are saying 100, 200 years. Okay. Any other guesses? Let me tell you that your estimation is off. It almost takes 300 million years almost takes up to 300 million years for the formation of coal to happen. 300 million years. How much time did we take to take away all the coal that we had, all of the coal to be just vanish? 300 odd years. Count starting from, let's say, industrial revolution, almost 300 years. So something that you built up in 300 million years, you have consumed it within 300 years. So just imagine the difference that you have between your consumption rate and the replacement rate. So that's why these are non-renewable sources. So renewable sources where the consumption rate is slower, replacement rate is faster, and non-renewable sources where your replacement rate is slower and consumption rate is faster. All right. So that's why this is how we define what is renewable energy. So here we would say that consumption rate is faster than replacement rate. So that's why coal, petroleum, and natural gas, they are counted in renewable energy. Sorry, non-renewable energy. Now there is one more source. We see, you can see the list of solar energy, wind energy, biofuels, and geothermal energy, and you can see coal, petroleum, natural gas. There is one more source, nuclear energy. Now, if I ask you, okay, another question for you, whether nuclear energy is a renewable energy source or nuclear energy is a non-renewable source. This is my question for you. Whether nuclear energy is renewable or non-renewable. Answer in comments. Tell me in the chat whether you think it's renewable or whether you think it's non-renewable. Okay, some of you are saying renewable, not consistently renewable. Very nice answer. Non or renewable both. Okay, that's also correct. Okay, can you tell me the reason? I mean, whatever you feel the answer is, can you also think of the logic? Why do you think so? Why do you think it is renewable, or why do you think it is non-renewable, or why do you think it can be both? Okay, renewable base, it is non-renewable, correct? Hmm. So let me tell you the problem. The problem is with the definition itself. The problem is with the definition itself. Now, what happens is that in case of nuclear energy is not consistent in the manner that we see it. So, for example, right now, the present state that we are in, we use uranium. We'll go into the details of nuclear energy in the next class. Don't worry about it. But in the present state, nuclear energy largely we are getting from uranium. Uranium is a mineral, finite quantity in the earth. So, of course, not available always. So, that's why, from that perspective, call it non renewable. There's the other perspective. The other perspective is when we look at the future of nuclear energy, nuclear fusion, where we have been successful experimentally, but we haven't been successful at a commercial scale. If we are at some point of time in the future, if we are successful with nuclear fusion, then it's renewable, then nuclear energy becomes renewable. Again, there is some kind of reactor design as well. There are certain kinds of reactors which can make nuclear energy renewable. These are called as breeder reactors. Again, we'll go into the details in the next class. So depends on the perspective, depends on how are we looking at nuclear energy. Because if we are looking at the present state of nuclear energy, call it non-renewable. If you are looking at the future prospects of nuclear energy, call it renewable. So that's why it is a very difficult task. If, let's say, UPSC asks you in the prelims examination, there is one statement which says nuclear energy is renewable energy or nuclear energy is non-renewable energy. True or false? I would say go to the next question, because we don't know. We don't know who has set the paper. We don't know what perspective they have taken while setting the question. So we can never answer this question, because if we are looking at the present, as I told you, if we are looking at the present state, I would say non-renewable. If we are looking at the future prospects, I would say renewable. That is where the problem lies with nuclear energy, because there is another way of looking at renewable and non-renewable energy sources. Renewable energy sources are clean sources, right? Solar energy, wind energy, geothermal energy, biofuels, these are clean sources of energy. Look at non-renewable energy, coal, petroleum, biggest polluters of the world. So when we are looking at pollution perspective, again we will say that okay, nuclear energy is carbon free, so call it as a renewable energy. But nuclear energy also has radioactive pollution, so can't call it as a renewable energy. So there are a lot of these kinds of debates when it comes to nuclear energy. So it's very difficult to place it in one of the brackets. To say whether it's renewable or to say whether it is non-renewable becomes very, very difficult for us because of all these problems. So that's why if UPSC asks, move to the next question, forget about it, because this will never help you solve any problem. So this is the first way of classifying on the basis of renewable energy and non-renewable energy. The second way to classify is on the basis of conventional and non-conventional energy. So conventional energy sources are the sources that we have been using conventionally, that we have been using for a longer duration, longer time. That's why we say that these are conventional. And non-conventional is where we these are newer sources. For example, solar energy, wind energy, we have been using commercially. We have understood how to use commercially only in the last 30, 40 odd years. So that's why non-conventional. So that's the second way to classify energy. Largely what you will see is that all the conventional sources are non-renewable, all the non-conventional sources are renewable. But that's not a rule, that's not a law, because there are sources which are non-conventional and non-renewable at the same time. For example, something that we will discuss later, or not probably today, maybe tomorrow, shale gas. Non-conventional and non-renewable both at the same time. How? Why? We'll discuss. So this is how we classify energy. First, we will start with non-renewable energy sources, starting with coal. Now, when it comes to coal, we know that coal is a fossil fuel, altered remains of prehistoric vegetation, originally accumulated in swamps and peat bogs. What do we mean? What is the meaning of this particular sentence? Now, when we say that it accumulated in the swamps and the peat bogs, what we see with coal is that the formation of coal might have begun on land. In the areas which are swampy areas, wetland areas, in these kind of areas, the vegetation that was growing in these areas, they might have been submerged under land because of some reason, because of geological activities, because of seismic reasons. There could have been any reason. Because of all these reasons, all the vegetation that was growing in all these swamps and wetlands, they got submerged under land. As they got submerged under land, they mixed with sediments, they were subjected to high temperature and high pressure, and under the effect of high temperature and pressure, organic conversion of all these vegetation into coal started. So the formation might have begun almost 360 millions to 290 million years back. And from there on, we see that buildup of silt and all the other sediments, together with the tectonic movements, they would have buried the swamps and the peat bogs, often to great depths. And then from there on, they were subjected to high temperature and pressure. And this basically helped them transform into coal. So in this manner, we see that how the conversion into coal might have happened over the years. So would have taken more than, that's why I said 300 million years, more than 300 million years. Now this coal, what we see is that there are four different types of coal, which depends on how much of temperature and pressure they were subjected to. So for example, wherever we see that the time has been, wherever they have taken longer amount of time, wherever the heat and the temperature that they were subjected to is higher, you see that better quality of coal will be formed there. All right. So for example, when you look at peat, So in case of peat, it took lesser time, not subjected to very high temperature, not subjected to very high pressure. So in a manner, complete conversion into coal did not happen in terms of peat. In case of lignite also, a better conversion happened, but still not as good as the other two, not as good as bituminous or anthracite. Because in these two cases, what we see is that in these two cases, they were subjected to higher temperature and higher pressure for longer duration of time, right? Subjected to higher temperature and higher pressure for longer duration of time, and under this they basically got converted. So for example, when you look at these four photographs, if you see peat, what you see is that peat has a woody appearance, looks like the bark of a tree, does not really look like the kind of coal that you are used to seeing, right? Doesn't look like coal. So this is what peat is, that complete conversion did not happen. Complete conversion did not happen, subjected to lower temperature, lower pressure for a shorter duration of time. So that's why peat did not completely convert into coal, and that's why it's not the good variety of coal. A lot of impurities, a lot of pollution, and not a lot of energy. And that's why when you go to Coal India website or Ministry of Coal website, they don't even call peat as coal. They say peat and they say coal. So they have taken they keep it different, because they know that peat is not something that you use industrially, can't be used in electricity generation, can't be used in iron and steel plants, can't be used in smelting, can't be used in any one of these activities, and hence we see that they keep peat separate and then they say coal. Then you have lignite. Lignite is also sometimes called as brown coal because of the appearance, as you can see here. That although it looks like the coal rock, but again has a brownish appearance. Again, impurities is high, so energy output is lower, and so that's why not really used as much as the other varieties are used. Then comes bituminous. Bituminous often is also called as industrial coal, also called as industrial coal. And India has a very large deposit of bituminous. India has a very large deposit of bituminous. It is used in iron and steel plants, it is used in electricity generation, can be used as domestic fuel as well. And this is the type of coal that you actually call as coal. I mean, both of them, I would say, these are the coal that you're used to looking at. But in India, anthracite is very rarely found. We largely see that India has a lot of bituminous. So bituminous coal is the best variety of coal that we can use, because anthracite is almost absent. Otherwise, anthracite is the best variety of coal, because the carbon content is higher, impurities are lower, so burns with a better efficiency, burns with a very less pollution as compared to bituminous or even the other varieties. So both these variants still, whether it is bituminous or anthracite, I would say that these are better variants of coal, because they were subjected to higher temperature and pressure for longer duration. Higher temperature and pressure, that's why with longer duration. So that is what we have seen with it. And anthracite is the best variety. So if you look at the comparison, if you look at the comparison of all these four variants, so in case of peat, as you can see that the carbon content is very low. Carbon content is very low. Largely we see that it is lesser than 40%. Less than 40% carbon. So everything else is impurities. In case of lignite, it's largely between 40 to 55%. Largely between 40 to 55%. In case of bituminous, it is between 55 to 80%. And in case of anthracite, it is largely 80 to 95%. So this much of carbon in these kind of coal. So obviously efficiency is very low, low in lignite, high in bituminous, and very high in anthracite. Ash and volatile matter content very high in peat, high in lignite, low in bituminous, very low in anthracite. And that's why because efficiency is very high in anthracite, very low amount of smoke, etc. So it's a cleaner burning as compared to any other form of coal. Now, when it comes to the areas where they are found, if you look at this map, you will get an idea of where we find this coal. So, for example, when you look at the coal reserves in India, this central part, this part that you see, this is where largely the bituminous coal in India is present. This is where largely bituminous coal is present. This part in the northeast is where we have peat. This part in Jammu and Kashmir is where we have anthracite largely. And these areas of Rajasthan, Gujarat, and here in Tamil Nadu and Puducherry, these are the areas of lignite in India. Right? So this is the distribution. But again, compared to all the other areas, this central part of the country where you have Jharkhand, Odisha, and Chhattisgarh, apart from that, all the other states, as you can see here, even Andhra Pradesh, Telangana, Maharashtra, Madhya Pradesh, parts of Uttar Pradesh, West Bengal, and even small parts of Bihar. All these are the states that have the bituminous presence, out of which the top three states obviously are Jharkhand, Odisha, and Chhattisgarh. Jharkhand number one, then Odisha, and then Chhattisgarh. So these are the top three states when it comes to the coal reserves in India. And we, in a manner, you can say that we are blessed with a lot of coal. Thankfully, you can say for the Indian economy that we had a lot of coal, because you know what happens with petroleum. We don't have petroleum reserves. We don't have a lot of petroleum reserves. So we have to import so much of petroleum. We have to spend so much of money in buying that petroleum. But thankfully, at least there is one natural resource that we had, and which is coal. And India is among the top 10 countries in the world when it comes to the coal reserves of the world. So that's why, in a manner, you can say that we were lucky. Because just imagine the situation where we already don't have petroleum and we did not have coal. So all the electricity that we produce was traditionally coming from coal. Now we have been trying to reduce that usage of coal that we have, the dependence on coal that we have. But essentially, it's not that easy. Essentially, it has taken a lot of effort and a lot of money for India to get into this situation. So, thankfully, that's why I said that although, yes, I understand the pollution problems and everything else, but still looking at the state of Indian economy that we were after independence, thankfully, we had coal. But there's the other way, other problem also. If we did not have the natural resources, if we did not have the coal, possibly we wouldn't even have been colonized. A lot of colonies that the Europeans built were basically the areas which had a lot of natural resources, whether in Asia, whether in Africa or other parts of the world. So that's why that it's a very fine line to draw what happened and what not. So looking at how we look at coal and the use of coal, the most important use of coal is in thermal power plants. What exactly do we do in thermal power plants? We use heat energy and convert it into electricity. Heat energy from where? From the combustion of coal. Heat energy coming from the combustion of coal. Heat energy from the combustion of coal will be converted into electricity. What exactly happens? Just have a basic idea of the components of the thermal power plant. So what happens is that first of all, the coal that we have mined will be transported to this thermal power plant. Goes to the coal hopper. Coal will be properly washed. All right, coal will be washed, and any impurities, dust particles, etc., whatever it might have had, all these things will be cleaned up. Then after that, it goes to a pulverizer. Goes to a pulverizer. The role of pulverizer is, this is where pulverization happens. So pulverization of coal is carried out. Pulverization of coal basically is the process where the blocks of coal Blocks of coal are broken into fine powdered coal. Blocks of coal are broken into fine powdered coal, meaning that big blocks, the rocks of coal that you have, will be completely crushed so that fine powder of coal will be produced here. Why to do that? Because when we do it, this basically increases the total surface area. This increases the total surface area. Total surface area available for combustion. Total surface area which is available for combustion. So that area increases when you crush it down to fine powder, so better combustion can happen. All right, this increases the efficiency of combustion. This increases the efficiency of combustion. So that's why pulverization will be done, and then after that we see that it will be sent to the furnace. The furnace is where the combustion of coal will happen. So once the combustion of coal happens, a lot of heat energy is produced here. This is where it comes in contact with water. It comes in contact with water. Now this water, as soon as it comes in contact with heat, of course it will get heated up, it will start boiling, and it will convert into steam. Right, it will convert into steam, and as it converts into steam, we see that this is where it will be taken to the turbine. It will be taken to the turbine, and from turbine it goes to alternator, and this is where electricity generation happens. Then this steam is fed into a condenser, and again it is converted back into water, liquid water. Again, as a feed water goes back to the furnace, goes back to the boiler, and in this manner this cycle continues. And this cycle is called as Rankine cycle. This cycle is called as Rankine cycle. So Rankine cycle, just remember what is Rankine cycle: where you have the plant, the turbine, the condenser, and the pump. When you have this kind of a cycle in any situation, it will be called as a Rankine cycle. We'll see that in thermal power plants, Rankine cycle is used. We'll go to geothermal electricity. We'll see that there also Rankine cycle is used. We'll go to nuclear power plants and we'll see that there also Rankine cycle is used. So Rankine cycle is constant. Rankine cycle is used in all these cases. Wherever heat energy is being used to convert into electricity, we'll see that Rankine cycle is used there. So this is how we see that electricity is generated. Now, as of today, what we see is that almost 55 to 60% of our electricity, 55 to 60% of our electricity basically is coal dependent. 60 40 50 55 to 60% of electricity is coal dependent. 5 years back it was almost 70%. Before that, almost 75%. So we have been decreasing our dependence on coal. We have been decreasing the dependence on coal because very simple reason: we understand the problems that coal creates, the pollution, the climate change, the wastage of fresh water. There are so many problems that coal has. What is the advantage? The advantage is the ease of use. That using coal is easy, generating electricity from coal is easy, maintenance of the plants is easy. So because of that, we keep on using coal, and we kept on using coal for the last 250 years. I mean, I'm talking about the world, not only India. So we kept on using coal for such a long time. Now we have reached a situation where we have created unsolvable problems for the earth, and that's why the world now realizes the problem that the world is in. And that's why we now see that drastically every country is trying to reduce their dependence on coal, because they understand the problems that coal creates. It's not only a long term problem that might happen 100 years from now, but look at the air pollution deaths happening every year across the world. It's a very menacing situation that we are in, and that's why we need to reduce the dependence on coal as much as possible and as quickly as possible. So disadvantages: huge wastage of fresh water, pollutes the atmosphere, and at the same time, global warming is also a biggest problem. Is a big contributor to global warming. So that is also a big challenge that we see when it comes to the coal-fired thermal power plant. So that's why in this particular problem, this particular manner, we see that there are all these issues that we have been creating, that we have been uh, looking at. And that's why when you look at the disadvantages versus advantages, disadvantages completely outweighs any kind of advantage that you can think of. And that's why whether it is India, whether it is all the other parts of the world, they will have to ensure that they can reduce their dependence on coal as quickly as possible and as much as possible. We have to go to a zero emission state, not only reduce it, but go to a zero emission stage. There's a wonderful book that Bill Gates has written on how to solve the climate change problems. Wonderful book to read, and he has given all the data possible to tell you about the problems that coal has created and why today it's not only about reducing. You can't be happy just by reducing 10% or 20% of the uses that the usage that we have today, but rather you'll have to reach a situation where zero carbon emission is being done, zero carbon emission. So it's not only about reduction today, the state that we are in as the entire world, we will have to go to a state where zero emissions can be ensured, and which is a very, very difficult situation to even think of the way we have been using coal altogether. So, and that's why he has written all that in his book, and it's a wonderful book to read with all the data that you have about going towards a zero carbon emission. So so that's why the disadvantages completely outweighs any kind of advantage that you can think of. Now, coming to the one of the biggest problems that coal creates is the coal ash. Coal ash, the impurity, the leftover when the coal combustion happens. As you can see in the picture, there are two different types of coal ash that you can see. The first one, the fine coal, is also called as fly ash. Fly ash, very fine powdered impurities which are left over when coal combustion happens. And then on the other hand, you have this kind of ash which is also called as bottom ash. Now, bottom ash, as you can see, that it is the bigger particle which often just settles down in at the bottom of the furnace, easier to remove, easier to dispose, and easier to recycle. Fly ash, on the other hand, very fine powdered silica material, very easily just gets off from the smokestacks, can very easily just spread in the air nearby, deposit on the land nearby, deposit on the water bodies nearby, and create a lot of problems and lot of health issues as well for not only humans but even for the plant and the animal life. So that's why we see that fly ash becomes a very major problem, and we need to do something about it. So fly ash, in general, when we look at coal ash, we see that it becomes a lot of problem because it contains lead, arsenic, mercury, cadmium, and uranium. So all these kind of impurities or uh, pro- metals, poisonous metals, are also present in coal ash, which adds to the problem. So first we have the fly ash. So fly ash, as I told you, fine silica, powdered silica material, which is formed when pulverized coal or the fine powdered coal is burnt. And then you have bottom ash, which is a lot more coarse material. Sorry, the spelling is wrong. A lot more coarse material which settles down at the bottom of the furnace. At the same time, we also have boiler slag and the flue gas desulfurization material. Now, when we look at these two, they basically also are a kind of, you can say, a kind of bottom ash itself, where we see that it is composed primarily of silicon dioxide, aluminium oxide, iron oxide, and calcium oxide. All these things are present in the boiler slag. Although boiler slag or flue gas desulfurization material, they are not a very big problem for us. their quantities are smaller, they are manageable. The biggest problem is with fly ash. The biggest problem is with fly ash, and that's why we need to look into the disposal and the recycling of fly ash. So the disposal, if you think of that, how exactly can we do the disposal? Disposal can be done either by land filling, that you dig up land, uh, uh, just take all the fly ash there and just try to cover it up. Or we use abundant mines. Many times the mines that are used and there is no mining activities happening there, we see that a lot of coal ash will be dumped there. So this is one way in which we try to dispose. Recycling wise, we see that there are a lot of construction activities. There are a lot of construction activities where we can make the use of this fly ash. It can be used to mix with Portland cement. It can be used to mix with the bricks. You might have seen this kind of a brick, the gray colored bricks, many a times used in construction material. So this is a kind of brick where fly ash is also mixed. So that's why we see that it can be used as an additive in cement or grout or concrete, can be used in the road material, can also be used to control the snow on road. This is about bottom ash. And then again the bricks etc is also where we can make the use of this fly ash. One more topic which is very very important from the perspective of coal is coal gasification. Last couple of years we have seen that the government of India has been talking about this coal gasification. So as a current affairs topic it becomes a very important area, because budget allocation also has been done to this coal gasification. So try to understand what do we mean by coal gasification. So coal gasification is the process of converting coal into synthesis gas, something which is also called as syngas, or also called sometimes as synthetic gas. Also called as synthetic gas. Because if you look at the annual report that was published by Coal India, you'll see that there they have written, use the word synthetic gas. So synthetic gas, synthesis gas, syn gas, everything basically means the same thing, where you have a mixture of hydrogen and carbon monoxide and carbon dioxide in smaller quantity. All right, mainly hydrogen and carbon monoxide, smaller quantity of carbon dioxide could also be present. Now, in this case, we see that coal gasification. We are saying that this is coal gasification, meaning that you take coal and coal is directly converted into a gas called as syngas. So that's why there is a high pressure vessel which heats coal to temperature of almost 1200 to 1500 degrees Celsius in the presence of steam and oxygen. And this is where we see that there are basic breakdown of the chemical components that happens, and coal converts into coal gas, into syngas. Now, this conversion that happens into syngas has a lot of advantages, and that is the reason why we are now trying to move towards this kind of a process. That the government of India wants that even in electricity generation, instead of using the normal combustion process, India should move towards coal gasification. So, what is the advantage? First advantage is that it's a cleaner burning, does not produce a lot of impurities, does not produce a lot of smoke. So that's why pollutants like sulfur dioxide, nitrogen oxides, particulate matter etc, they are much lower in quantity as compared to the normal combustion of coal. So that is the first advantage. Then the efficiency, we discussed about Rankine cycle, right? What happens is that generally speaking, when we look at Rankine cycle has a very low efficiency. Typically, we see that Rankine cycle would have an efficiency of just about 33%. So that's why it's a very inefficient process. In case of coal, especially, it's a very inefficient process. Now, when it comes to coal gasification, the energy conversion can be as high as up to 95%. So that's why from the same quantity of coal, you'll be able to get better quantity of energy. You'll be able to get better efficiency from the same quantity of coal. So that also is one of the advantages. Then it is more versatile, because there are large applications for which syngas can be used for production of electricity, for to be used as a fuel, then after that even for heating purposes, and even the production of chemicals and other products, even for example fertilizers. Even for producing fertilizers, we see that the same syngas can be used. So that's why we see that it becomes also very versatile. Then environmental impact is reduced because it's a cleaner burning, less wastage, less pollutant. So of course it has an uh, advantage there. And it can be used to enhance our energy security, because from the same quantity of coal that we have, we'll be able to improve our efficiency. So that's why we'll be able to improve upon our uh, energy security as well. So from all those perspectives, when we look at coal gasification, it's a very very important process that we can actually use in the coming years. Look at this question. This question was asked in your 2020 paper. It's an easy question. Please read the question and then I will launch the poll for you. Please mark your answers. Wow, wonderful. So 88% of you have marked the correct answer. I couldn't have hoped for anything better by the time the class ends. So wonderful to see. With reference to fly ash produced by power plants using coal as fuel, which of the following statements is or are correct? First statement, fly ash can be used in production of bricks for building construction. We saw that picture. Perfectly correct. Fly ash can be used as a replacement for some of the Portland cement contents of concrete. We discussed that. Grout, cement, concrete, mix it with anything that you want. Fly ash is made up of silicon dioxide and calcium oxide only, and does not contain any toxic element. I mean, the whole problem is toxic elements. So can't say that there is no toxic elements here. So that is wrong. So correct answer will be A. That is 1 and 2. And when you see terms like only, etc., which are very extreme words, most of the times, whenever you see the use of these kind of terms, take it for granted, it's a wrong statement. So that is what we see here as well. And that's why the correct answer will be 1 and 2 only. Let's stop here because I don't think I can start petroleum and complete today. So let's stop our session here. If you have any doubts with regards to whatever we have discussed in the last 1 hour, please let me know. We'll have a discussion on that and then we shall end the class for today. Next class, when we come back, we'll start with petroleum, we'll go to the renewable energy sources, and then we will go to nuclear energy. These are the things that we'll discuss next. Anthracite is less smoky. Yes, it is. The smoke content will be much lesser as compared to any other form of coal. It is the best quality of coal. Yes, it is the best quality of coal. What is hydrogen fuel? How stable it is? Hydrogen fuel is when you use hydrogen as the fuel instead of using any other source that we are using. Stability wise, we are still trying to achieve better stability. It's not that we have been able to. Right now, the entire process of production of hydrogen remains very costly, and that is one of the major problems that we are facing today. My doubt is that when should we do PYQs, after completion of subject or before? I would say that do it topic wise. I mean, as soon as you go with the topics, you should start doing it, uh, because see, PYQs have to be done to see whether you have understood the topics well or not. That whether after reading the topic, whether after reading the subject, can you answer the question. It's not that they are going to repeat the question. It's just that it gives you an idea about what kind of questions come and what you should do if you are preparing for this subject or for this examination. So try to do it along with the subjects, as because even if you try to do it before the subject, first of all you will not know the answer. The most that you can do is you can understand that this is the pattern, but doing after the subject completion will at least give you a perspective and you can attempt those questions. But there is no topic wise PYQs, only year wise questions. No, for example, I have been doing all these things. I mean, I, for every topic, wherever there is a relevant question that has come, we are discussing that. If you want to do it, I mean, year wise, you should do after you have completed everything. But because if you do that before, you can only understand the pattern. So if you want to understand the pattern, that's great. You can do it from the PYQs. But if you want to really solve those questions, you will have to first complete those areas and then only you can go there. So if you want, you can even, I mean, the recorded lectures, the tablet lectures that you have, we have completely done PYQ separately also there. You can go and watch it there also if you want. So there we have done the segregation subject wise. You can do it. Right, wonderful. So I think this is the end of the session for today. Thank you very much for joining in. I know this is a technical subject, not very easy to grasp, but please go back, revise everything over the week. If you have any doubts, you can always come back to us. If you want to contact me over any doubt that you have, this is the email ID, rasesh.kumar at byju's.com. So you can contact me here, or you always have all the support email IDs. You can go to islive at byju's.com, target is at byju's.com, and you can always reach us. Right. So this is the end of the class for today. Thank you very much for joining in. Please go back, revise everything that we discussed, and let's meet back next Saturday. Thank you.